Welcome back to the AnKorage, where everything is awesome and I'm not so much half the time. But either way, the video series that we just completed was getting a Raspberry Pi set up as a file server. Very simple one, but this is to continue it. It's a bit of a bonus, so that's nice. So what do we have set up? Well, now that we've actually configured everything and you got it up and running, you need to maintain it. Or ideally, you want to maintain it. You want to keep the kernel up to date. You want to keep all the software, the Raspberry Pi, up to date. And this is the bonus where I show you how to do that. So what we're going to do is we're going to switch over to that actual Pi, and we'll take care of that. So we'll just switch over to it here. And so as you can see, this is the login and such. So I'll get that, and I'll drag this down here. So what we've got is, you have all of this information in here, and what we want to do is ultimately, just for the sake of, demonstration, if you type in the word clear and hit enter, it clears out and you get brought back to your cursor and then command line prompt up at the top of the screen. So what we have to do first is we have to update the software of sorts. But the first thing you have to do is tell it or get it so that it can see that there are updates out there. So I'll give a couple of definitions as we go along. The first thing we type in is sudo. Now, what is sudo? Now, it's a program for Unix type computers that will give you basically give you administrative permissions. So, and it's a couple of different words mushed together. And Linux and Unix is, they're famous for that. It's like if you want to list what's in a directory, you hit ls for list. But this one here is a couple of different words. You get S, U, and then do. S, super, the U is user, and then do. So basically it means super user do, but we say sudo. You can say sudo if you want to be like that, but it looks like sudo, so you say sudo. So at that point, so the next thing that we need to punch in is we punch in apt. Now what apt stands for is that this is the Advanced Packaging Tool, APT. And what this does is that it works with the core libraries of the operating system. So you're basically telling it to go out to the libraries, and you want to update it. So sudo apt update, that is the command altogether. And now it's going out and it's reading all of the package lists out in in those locations that are listed up there, the archive and Raspbian, stuff like that. And so it reads everything and it says 5 packages can be upgraded. And if you want to see what upgradable, it actually says run apt list upgradable to see them. So you punch in apt list 2 dashes upgradable. And this tells you all of the individual packages or programs that is upgradable. And it'll say, hey, it's upgradable from one version to the current version, which would be the one here. So at this point, to do the actual update, where it says update here, you're just updating the package libraries in the Raspberry Pi. Now to upgrade it, you actually just punch in sudo apt upgrade like that. And it will go out and it will read the information, stuff like that. And and then if there's anything that can be removed, like this one here, libfuse2 was automatically installed and is no longer required, libfuse 2. So we don't need that program. So after we do this, we'll actually go ahead and get rid of that. And it actually tells you, use sudo apt auto remove to get rid of it. So we'll take care of that in a minute. So we'll just go ahead and where it says, do you want to continue? It actually says Y, capital Y or an N. Well, you could punch in capital Y, you could punch in a regular Y, or you can just hit enter. Yeah, which is what I generally do. I just hit enter for it to go ahead and to take care of that. So in this particular update, the actual Linux kernel has an update. So this is going to take a little bit while it updates the kernel. So I'm just going to shoot right to afterwards, and we will pick it right up after that. And just as a heads up, you can see there's a progress bar down there using ASCII characters. Sometimes, if the updates are large enough, or it's actually told to do this, you'll get this little progress bar so you can see the progress of the update. It doesn't always appear, but it does on big updates or important updates. It's kind of nice to see it. So we'll come right back. Okay, so that's done, and it's all complete. And it took this one took about 10 minutes, mainly because it actually did update the kernel with the most recent release of the kernel. So once that got done, you would punch in sudo reboot. Now, just like we were doing before. So we would punch that, and it will go ahead and do the reboot. So as a super user, you want to reboot, and now I want to do it right now, not on the next compute cycle, which would be in about which that usually starts on the next minute. Now, just to show you what it looks like when you do sudo reboot, it might actually do it right away, but sometimes it'll say, hey, especially when you go to do a shutdown, you would say just sudo shutdown. So I need to get this back. So get back to me. So so at that point, that is rebooting, updating the software on the Raspberry Pi, and making a reboot. You particularly want to reboot it right after you update the kernel. As far as rebooting after other updates of other software, you could do that right away, or you could wait a week or another day, stuff like that. You can basically, it's up to you how you want to do that. You could do it like the next day, the next week, like I was just saying. You could do it like once a month. Unless of course there's a kernel update, in which I always advise reboot it right away. You can also reboot it right away after every time you run updates on the software for your Pi. Another type thing is doing backups. What are backups? Well, what we would basically want to be doing is taking an image of the actual full drive, so that should something go corrupt on the Raspberry Pi, on the microSD card, you've got an actual picture of it that you can actually put onto it and then just fire it right back up. So we'll talk about that. So what we want to do is, there are ways, let's say like in Windows, where you can actually take an image of an actual drive. But what we want to do is we want to go out and get a piece of software where we can actually do it a little easier. And this is what I've seen as being the simplest way to do this. And that is going out and getting the Win32 disk imager from SourceForge. And you download it and you install it. And we will be looking at that in just a moment. But what this does is that this allows you to take an image of an actual, let's say in our case, of a Raspberry Pi SD card, and you can also write using this as well. So this can be used for both purposes. Okay, and once you've got that downloaded and installed, you want to actually go out there and actually pop it up. You go into it and you're actually brought into a very simple interface, which is this. And this is where you can do everything you need. So let's see if I can do this here. So when you come in here, what you want to do is you want to select the place where it's going to go. I suggest just on the desktop, just for the sake of creating it, and then from there you can put it wherever you want. But you click on this, and you brought up to there, and this is where you can navigate to where you want to put it. You want to give it the file name, so you can call it whatever you want. MyPy, let's say. And it's already selected to have, it's a .img, so that's already there by default. So you just pick that, and it shows up right up here. And down here, these were all grayed out before. Now it's saying read. So what you have to do up to get to this point is you shut down the Pi. You remove the SD card, you put it into your computer, whether through the card reader that you have, whether it's using the little adapter that came with the card and you're sliding it into the card reader in the computer, or use the adapter, the separate adapter like I had to do, and then you fire up Win32 Disk Imager, and you might get a pop-up that says, hey, this program wants to change things or something. You click through it and this comes up, and then you can come over here and you can select your spot and such and get it all set up, and there it is. So from that point, you come down here. You don't want to touch hash or anything like that. You basically just click on read, and what it's going to do, and this is where it actually creates the image file. So you click on that, and it starts to read. You can see it's at 1%. And as you can see here, you've got a progress bar, so it's good to have while that's actually running. Now, depending on the size of your SD card, that actually predicates, or basically tells you how long it's going to take this picture or create an image file of the entire card. And this is why I pick the 16 gigabyte micro SD cards, is because this only takes about 8 minutes for that size. And for folks, let's say, that have a 32 gigabyte SD card, this will take about twice as long, because 16 times 2 equals 32. So it will take about 16 minutes for 32 gigabytes. And of course, the larger the SD card, the longer it's going to take. So for our actual needs for the Raspberry Pi OS, we don't need a whole lot. We could use an 8 gigabyte and get this done in like 4 or 5 minutes. But this is basically what it's basically running into. So I use 16 just as it's easier to get, because the lower amount of SD cards are slowly getting more difficult to obtain. Okay, so once it is done, that progress bar disappears and it shows up, let's see if we can get back to that. It'll say the read was successful, and it's just a little pop-up box that shows up right in here. But of course, you can't see it because I don't have it set up in OBS. But you click the OK button, and you're brought back to this. And just as a heads up, just as things like when you actually have this here, when you actually select it out in here, and you actually type in your file name, you do want to punch in .img, because the program doesn't automatically pop that in there. So you want to make sure, even though it's automatically set up for disk images, you actually want to say it's an image. So put in that .img, and you'll be brought back and you see how it's updated, and then you can do another read and it will actually go and create that for you. So and then there's the question of, okay, I've taken a picture or an image of the actual SD card. How do I actually go out and write it? And writing is the next part. So you've taken your image of the SD card, the entire thing. So basically what this means is this is a, it's an image, it's a picture of, it's backing up the entire card, the entire contents of the card. Basically what it is, it's a copy of it. And you can use that as a backup so that, once that's done and some time passes and for some reason, you decide you want to play around a little bit in there, you've done that, and then it doesn't work anymore. You can't seem to get access to your files and things like that. And well, what you might need to do in a situation such as that is, it would be easier if you could just take, well, I wish I had a copy of the entire SD card, put it on, and just kick it right back off again. This accomplishes that. So we've taken an image of the card. So now, what do you have to do in order to actually go in and actually get that put back on the card, so that what you can do is just write that copy onto the card, and then put the card back in the Raspberry Pi and just turn it on, and away it goes, and you're right back to where you were before all of the mess happened. So I'll show you how that's going to be done. Is you go back into Win32 Disk Imager, and you're brought into it. And so at this point, you have to go out and actually find that piece. And, I put it out on the desktop, and here we have my Pi. So I would select that, and you see how it shows up right here? And then down here, we see write, So what you would want to do at that point is you want to write it. And, you want to make sure that, your device is, the actual SD card, the drive that is actually created when you actually put it in. So, and then you come down and you click write, because, that's black now. It's not grayed out like cancel over here. You click write, and then you'll get a pop-up box that shows up right here that says, writing to a physical device can corrupt the device. Are you sure you want to continue? You would click yes, and so then you're brought back into that, and it's actually going through and it's starting to write, and you're gonna get the progress bar going through as it writes. And as it goes along, it'll give you the progress bar. And writing, it takes about the same amount of time to write to the SD card as it does to read from it. So that's basically that. So what you want to do is you want to basically ask yourself, how often do I want to do this? As far as doing this image writing backup, that's entirely up to you. But some people would want to do it every single day, every single week, every single month, something like that. But I would say that the only time you ever really should do a backup is when you have a kernel update, when you see that the kernel's being updated. And you can see that when you run the apt upgrade, and or the upgradable, when you run the apt list upgradable, and you happen to see stuff in there for the kernel. So my recommendation is doing one of these image backups after a kernel update. You just have to watch for it. But that's basically that. And that's taking an image or a picture of the actual SD card and having it as a backup of your Raspberry Pi or of the file server, so that should something screw up and you can't seem to access it, you can just burn a copy of that backup onto the SD card, slide it back into the Raspberry Pi, turn it on, boot it up, and away you go as you were before everything did that. And but yeah, I would say do that after you do a kernel update, but you can do these backups whenever you really want. So, and as far as running the package updates, it's the same thing. You can do it every day, you can do it every week, once a month, stuff like that. I would do it every so often. You choose what you think would be the best, but you really should do it in order to keep things up to date and stuff like that. And it helps keep it secure, because a lot of them are security updates and things of that sort. So that basically completes this series as a whole, including this bonus. So it was fun putting it together, and you got to see this face the whole time. So I am going to probably be doing one more video, because I've decided that I'm going to be moving most of my projects out onto PixelFed, because it's easier to do. I can just take pictures, load it up, or do really short videos, like maybe a minute long. Just really quick stuff I can use with my phone or whatever, and then just throw it up there. It's just easier to do, and because doing stuff out here is a little more involved, and something that would normally take, let's say, like an hour to do, could take an afternoon, or a few hours, just because of having to deal with cameras. So I've talked enough, but I will see you in the next one, which there should be one. It is going to be computer related, but we're not getting into computers or anything like that. We're going to be getting into cosmetics, and I'm not talking makeup. I'm not talking, blush or foundation or cover up or lipstick or anything like that. This is going to be cosmetics of let's see, Celeria and Odin. I'll only be doing one of them, and that's for the sake of some decals that I happen to get, and it's going to be for the folks that I got the decals from, which is A1 Decals. They happen to be down in Kentucky, and they are awesome. So we are going to do that. So, and like I said, I've talked enough. Thank you very much for coming, Skál. And we will see you in that video when it comes out. Thank you very much. We'll talk to you later.